Okay, we have to take another integral. This one's from the MIT Integration Bee 2015, number 7. We have the integral of 1 over x plus 4 times the square root of x plus 5 dx. Okay, I thought this one was pretty interesting because what we have here in the denominator, it's actually a quadratic, but not a quadratic in x. It's a quadratic if the variable is like square root of x. For this first x right here, I can write this as square root of x squared. And so what I'm thinking, in order to clean this up, let's do a u substitution on just square root of x. And then in order to get our dx value, let's just solve for x. Squaring both sides, we have x equals u squared. Take a derivative on it. Dx is going to be just 2u du. I'll go ahead and substitute. Now we're going to have this 2u du in the numerator. And then we transform the denominator. It just becomes u squared plus 4u plus 5. But I can't actually factor this with integers, so partial fractions is not really going to be an option for us here. I think what I want to do is we could do another substitution on all this, because you'll notice when we take the derivative, we're going to get a 2u back. So for this, we'll use another variable. Let's call t equal to this whole denominator. We'll say t equals u squared plus 4u plus 5. Take the derivative. We have dt is going to be just 2u. Derivative here is going to be a plus 4 du. So in order to set this up, let's get our dt into the numerator. So I can just add a plus 4 here. But of course I don't want to change it, so let's subtract off a 4 as well. So we're just adding 0. But what I actually want to do with this is let's use this to create a second integral. So over here, what I'll do is I'll bring a minus 4 out front, and we'll just have the same denominator here, u squared plus 4u plus 5. But then substituting over here, this is just going to become really simple. This is going to become just dt over t. Then over here on the second one, what we can do is, like I said, we can't factor this, but we can complete the square on it. So how we'll do that is if we'll start with u, take 1/2 of this, and we get a 2. So we can write this as u plus 2 squared. If you square this out, you're going to have u squared plus 4u plus a 4. Well, we have a 5 here, so let's just add a 1, and now this is going to be the same as this right here. Then integrating this first one, we're just going to have natural log absolute value of t. And then here, because we have the derivative of this is just going to be 1, so we don't need to substitute again. We can just go right to our arctan formula on this. Looking at this over here as 1 squared, this is just going to be 1. This is actually just going to be minus 4 here, and then we're going to have arctan of this, so it's just going to be arctan of u plus 2. And now all we need to do is just back substitute this in order to finish it off. Before I do it, let's just get a value for t in terms of x. So we're basically just putting it back to the way it was in the original. This is going to become for t, x plus 4 square root of x plus 5. So we'll back substitute, but this t value is always going to be positive. So I'm going to drop the absolute value. We can write it as natural log x plus 4 square root of x plus 5. And then here minus 4 arctan of u, which is square root of x plus 2. And we just add a plus c on there, and that's it. Okay, there you go. Good one today from MIT 2015. Thanks everyone for watching. Have a good day.